We now begin the last module where we'll talk about foundation models, specifically the focus on relational foundation models. So our goal is to learn what foundation models mean, specifically in the context of tabular and relational data. We'll understand some ideas, main ideas in the design of foundation models for tabular and relational data. We'll learn how to use, okay, what is the meaning of using a foundation model, actually, and then we'll delve into specific foundation models, understand their details. Okay, I'll start with some background and some reminders, starting with the concepts of tabular relational foundation models, and then we'll recall the concepts of attention of transformers, which are essential for foundation models. Okay, so foundation models. So basically, these are pre-trained models. They generalize through different tasks from different domains. Okay, so you train them on different tasks of the different domains, and then you are better off using them in some new domain. What is better off, we'll see later. Now, foundation models exist in other domains, like natural language. We're using them all the time, the LLMs. There are foundation models for incorporating vision, images, and text, or graph data and text. These all exist. We're not going to discuss these. We'll focus on tabular and relational um, foundation models. Okay. Now, uh, in our context, in our terminology, what's important is that foundation models are pre-trained on data sets of many different schemas. Okay. And this means that they can generalize, they are useful for new data sets without knowing the schema in advance. Okay, that's a crucial point. Okay, this means that they usually involve some way of encoding the data into a representation space of a fixed dimension, predefined dimension that is, used regardless of the domain, regardless of the schema. It also means that such a foundation model needs to capture the interplay between the schema, the metadata, and the data. We cannot longer assume that we encode the schema somehow in the model upfront and just let the data speak. No, we need to learn something about the schema itself, how the data interplays with the schema. Okay. Now, usually to do something meaningful, the architectures are using transformers. Okay, these are the objects to date that can actually generalize significantly to unseen things. Okay, and we see them in the examples. And I showed this slide in the past. I want to give it again. We're looking at different types of generalization, different types of machine learning in the relational domain. The transactive model means that we know the schema, we know the task, we even know the database. What we don't know are the labels of, say, some column or some task, but we learn over known labels of within the same database. So that's a transductive model. An inductive model means that we know the schema, we know the task. What we don't know is the database. So it means that we are training on one or more databases up front, but in evaluation time, test time, we can get a new database, but all over the same schema. We know the schema, let's say. Courses and students and lecturers, these are known concepts. That's an inductive model. Then the foundation model basically says we don't know the schema, we don't know the task, and obviously we don't know the database. We train on many things up front, many schemas, tasks, and databases up front, and then we are able to generalize to new data sets. Okay, so this is an important difference. And with our way of modeling problems, okay, our formal frameworks allows us to, they allow us to distinguish between the three types quite elegantly, basically based on the schema or the interplay between knowing the task, knowing the database, knowing the schema. Okay, now how do you use a foundation model? What does it mean for us that we trained something, we trained a model on many data sets, and then we can use them in a new domain, in a new schema? Okay, so there are several ways of using a foundation model. The basic thing is fine-tuning, where you basically say, well, I'll use the model that was pre-trained just as an ordinary learning pipeline. Okay, but I won't try. I won't start with random parameters, but rather the parameters that I learned, pre-trained, and then I'll refine them. Okay, I'll do fine tuning on my specific new domain, specific new schema and database or collection of databases. Okay, so what I described is basically many shots, but you can also think of few shot situations. And one way of doing few shot is to say, well, I may have many parameters because I need to generalize, but I'm leaving a small set of a small number of parameters that are designed for learning for the new task using a small number of examples, few shot. Okay. Now, another use is in-context learning, where basically we do not train the model in the usual sense. We do not touch the parameters, we do not update the parameters, we do not do gradient descent, nothing like that. At the evaluation time, we feed the model with examples as input, and from these examples, we generalize. Okay, and these will usually be few shots. Okay, but the important thing is not whether there are a few or many shots, it's the fact that we are not changing the model. The model is intact. We're just feeding it with examples before we're asking, the question of what it is that we don't know. Okay, this means that when we train the model, we need to train it not just to solve tasks, but to learn how to solve tasks from examples. We give it many cases of, here are a few examples, and then something that I don't know, and we wanted to generalize on that, be good on this learning task. Okay? Uh, and then there is the idea of prompting, which is basically taking it to the next step, where your description is not necessarily by means of a few examples or many examples, but rather a description from another domain, usually text, where you basically describe your task. Okay, don't provide any example, you don't provide any label data necessarily, you provide a general description of your task. And then again, what your model is trained to do is to solve exactly these kinds of tasks. Given a prompt, produce an answer. Okay, so these are the three ways of using foundation models.